Hello, this is Jesse. I'm going to be going over tutorial 4. So the objectives of this tutorial are to figure out what makes a multiple sequence alignment correct. We're going to create a consensus sequence. We're going to go over induced pairwise alignments. We're going to calculate sum of pairs score from a given multiple sequence alignment and create a multiple sequence alignment. So question 1, which of the following multiple sequence alignments is correct? Why are the others incorrect? Okay, so correct part A, we're going to put a gap here. Okay, there shouldn't be any sort of white space in the columns. So we look at each row, and then we have the columns right here, A, so that's good, G. Then we have a gap, which is good, and we look over here, there was originally a blank space here. We need to fill that up with a gap. This would make the alignment correct if there's supposed to be a gap there, which there is. So we put a gap there, and that's the correct alignment. Next, in this case, I accidentally already erased this, but originally there's supposed to be in the tutorial that I upload for y'all, there's a column with only 3 gaps. This would be unnecessary in the multiple sequence alignment. We can remove those and still see that we still have column A being aligned, column C having elements being aligned, and so forth. So this would make the multiple sequence alignment correct. And then in part C, this multiple sequence alignment is already correct. You notice how in each column there's an element in each section. Right, we have A, G, gap, C, gap, T, gap, T, A. Right, there's no blank spaces. So we have gaps we have gaps here, we have gaps there. So that's what makes a multiple sequence alignment correct, right? In the column, there's at least an element, some type of object in the section within that column. Next, we're going to write a multiple sequence alignment for the following, or we're going to write the consensus sequence for the following multiple sequence alignment. So for this, our consensus sequence is going to be first a gap. So we're going to write the element that occurs most often. So here a gap occurs most often in this column. In this column we have T. In this column we have J. In this column we have U. And then we're going to repeat that all the way down to the very last column. So we have T, J, U, M, C, gap, K, E, J, gap, so J, gap, and then we have I, we have F, V, U. So notice, only put the one that occurred most often. So each character that occurred most often in each column. Gap, T, J, U, M, C, gap, K, E, J, gap, I, F, V, U. Moving on, write an induced pairwise alignment of the indicated sequences. So here, we're going to create the induced pairwise alignment for the first sequence. So we have this case right here. We're going to remove these gaps, and then this would make our sequence correct, right? We have our induced pairwise alignment correct. So we have AT, gap J, good, K, good. We go all the way down. We have C right here. Then we have this right here. Good. So now it's going to be 1 and 2. Copy 1 and 2. Okay, so everything's good. up to about here. So we need to remove that gap. And then from there we still have characters being aligned, which is exactly what we want. And then we have, what's the last one? 2 and 3. We're going to take 2, and then we're going to take 3, then we're going to look, make sure everything's being aligned. In this case, we have a gap gap, unnecessary, we can remove that gap gap, and then we have what we want right here, and then making sure everything else is being aligned. Good. So we can move on. So that's the answers to question 3. We just did the induced pairwise alignment for sequence 1 and 2, 1 and 3, and then 2 and 3. After that, what we did is we just made sure we clear up any unnecessary gaps, and if you find a case where a gap may be missing here, then we just add the gap. Okay, so we're going to move on. Calculate the sum of pair scores of the following multiple sequence alignment given that match score equals 2, mismatch score equals -2, gap score equals -2, and gap gap equals 0. So here we have the multiple sequence alignment. Next, we're going to look at sequence 1 and 2 being compared, sequence 1 and 3 being compared. Then we'll look at sequence 2 and 3 being compared. So first, sequence 1 and sequence 2. So here we have a match. So match equals 2. So we have 2 matches, and then we have 2 matches, 1, 2, and then we have 2 gaps. Okay, next what we're going to do is we're going to look at this section. Here we have, looks like we have 3 gaps, 1 mismatch. And we'll say 2 matches and 2 gaps. Okay, and then next we can look at this section. We have, looks like we have 2 gaps and 2 mismatches. Gap, gap. Oh, this is gap, gap. So we have 1 gap, 1 gap, 1 gap, gap, and we have 2 mismatches. So mismatch, mismatch, gap, gap, gap. Double checking everything. 3 gaps, 1 mismatch. And on the top we have 2 gaps and then 2 matches. Next, all we need to do is sum them up. So we have a total of 2 matches. So 2 matches in total, and then we're going to multiply that by the score that we're given, which is 2. So we have 4. Then we're going to go up and then look at the total number of gaps. So here we have 1 gap here, 3 gaps here, and then we have 2 gaps here. So that will be 6 gaps. Multiply that by -1, and we get -6. Double check. Yes, gap score -6. Then we'll look at the mismatch. So we have 3 mismatches. 3 mismatches, multiply that by -2, and we get -6. Okay, then we look at gap. We only have one gap. Gap, multiply that by 0, and you get 0. So here we have -6, -6, so total equals -8. You just sum them up, -6 plus -6, -12 plus 4, and then we get -8. So that's the total, and that's the answer for question 4. Okay, moving on. Calculate the sum of pairs score for the following multiple sequence alignment. Given that match score, so this is the scoring scheme. Okay, so here we're given the multiple sequence alignment. Notice we're asked for the same thing, calculate the sum of pair scores given the following multiple sequence alignment. In this example, we looked at sequence 1 and looked at sequence 2, and then we just counted the mismatch, the match scores, or the gap score, or the gaps. We did that for all the possibilities, so say sequence 1 and 2, or all the possibilities, given that we aren't comparing the same sequence. We're not comparing sequence 1 to sequence 1, we're just looking at sequence 1 and 2, sequence 1 and 3, and sequence 2 and 3. So, and then we just counted the total gaps, total mismatches, total matches, total gaps, calculated the overall score, and then to calculate the overall score by summing them up, we got -8. In this case, we're using a different method. So the Pictogram method, or in some cases you might be given a multiple sequence alignment of only four sequences being aligned. But in this case, we're doing 5. So what you do is you look at the first column, and you're going to create the shape that would have 5 points. It's a pentagram. If it was 4, you would create a square. If it was 3, a triangle, and so forth. But here, example is pentagram, okay? Next, what we're going to do is we're going to use this to count the matches and mismatches and the gaps and the gap scores. So here, notice these dotted lines indicate that this is a match. So all the dotted lines count as a match. So if you count them, we have 1, 2, 3, 4, 5, 6, 7, 8. So here we have 8, 9, and that should be it, 10. So here we have 10 matches. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 matches. So just remember that the dotted lines just tell me how many matches. I just count the dotted lines, and that's how many matches there are. Matches. So we're going to move on. There's nothing else I need from this. So this is all that I got, all my information from right here. No mismatches, no gaps, none of that. Then we look at the second column. Use the second column right here. Second column. A, C, C, C. Okay, so in this case, remember that we have the dotted lines are matches. This time the solid lines are mismatches. So we have one mismatch we have second mismatch, we have a third mismatch, then we have a fourth, and we have a fifth. So we have 1 here, 2 here, 3 here, 4, 5, and then we have 6 right here. Okay, so that's going to be a total of 6 mismatches, and then we have 1, 2, 3, 4 matches. Four matches, and we have 4 matches and 6 mismatches. Next, we can continue on. In this section, same thing. We're going to be looking at this column here. A, C. And then we're going to calculate, or we're just going to count. Just going to be counting at this point. So here we have 1, 2, 3, 4. So we have 4 mismatches and 6 matches. Okay, next, all we need to do is sum them up. So here we take the total amount of matches. So we have 10 mismatches here, 4 matches here, and 6 matches here. So that's going to be 20 matches. And then multiply that by 2, if I remember correctly. Yes, so that's going to be 40. And take the total amount of mismatches, which appears to be 10. Multiply that by -2, and we get -20. Total equals 20. So here we have our total score. Now I'm going to show you an example you might get in your homework that might trip you up or not. So let's say we only have, let's make it, so we only have 4 sequences being aligned, and let's say here we have gap, here we have gap. So what we can do here is we'd still do the same thing. You just create a shape corresponding to 4 points because we have 4 in each column. So here's going to be our shape. And then from there, we will label them. And I'm just going to say the solid pink lines are going to be matches. So we have 1, 2, 3, 4, 5, 6. So this will be a total of 6 matches. But I'm going to focus on this point. This will be a little bit more interesting. Let's go green. So here we have a gap, and I'll put the other gap over here. Then I will put the A right here, the A right here. Okay, So now I'm going to still use the pink line as matches. This is a match. Okay. And I'm going to put orange as gaps. Gap. 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 And then we'll put the purple as gap gap. So in this case, as you can notice, 1, 2, 3, or 1, 2, 3, 4. So we'll have 4 matches here. I mean, my bad. We're gonna have, I labeled the pink as, or the orange as gaps. So we're gonna have 4 gaps. Here we have 1 match, and then we have 1 gap. Okay. So this gap gap, I meant to say gap gap. So gap, this is gap, this is gap, gap gap. So this would be a 0, right? If you're given like gap gap is 1 or something else, or 2, or -2 or -1, then you would score that accordingly. It's still the same thing. If you're not given a gap gap score, then this would be the final part. Right? You wouldn't even consider this. You just look at the amino acid or nucleotide here, and then just count the matches or mismatches, right? So here we have 4 gaps and we have 1 match. Okay, hopefully that helps you with your homework. And then moving on, gather 5 annotated sequences similar to human antimicrobial peptide beta-defensin. The gathered sequences should be from different species and have significant e-values. With these gathered sequences, create a multiple sequence alignment, and then it asks, what do the symbols, we have a star, here we have the colon, and then we have the period. So what do they indicate? What does their absence indicate? Okay, so let's open up a web browser. I'm going to go to Uniprot, Internet, refresh this. Once I have Uniprot open, this question already gives the accession number. So I'm going to click on the accession number, click search, and then here I'm given straight to the information page of this particular peptide. Now, it's asked to gather sequences. So here what we can do is we can actually we can use the BLAST search for the BLAST algorithm that's implemented for Uniprot. Okay, so we're going to do that. BLAST, default, and go. Notice that it's giving the Blossom 80 matrix. The sequence is relatively short, so we're going to go with a Blossom matrix. They're going to automatically substitute the Blossom matrix 80 in for you instead of you having to manually do it to compensate for the shorter sequence. So the sequences need to be more similar because they've had less time to evolve compared to larger sequences. Okay, once we have our results back, we can start filtering them based off the criteria that we were asked for. So different species and have significant e-values. So first, we could go with reviewed. So these are proteins or sequences that have been annotated and they have been given annotated scores. Have they been determined experimentally, have been determined by a software, and so forth. So these are reviewed. So here we have some proteins. So we need good e-values. So far, these e-values are relatively small. Closer to 0, the better. Now, the other question asks for 5. So it asks for 5 annotated sequences. So we're already at the end. These are annotated. These have been reviewed. And then now we just choose some of the peptides that are some of the search results that are from different organisms. Okay, so we're going to first choose the first one, which is the peptide itself, or the best hit, right? 103. And we can choose humans. And then we can have the gorilla. And let's go with lower identity scores. We have the mouse, the rat. Let's go with the pig. Okay, that's 6. We'll just go with 6. More than 6, more than 5 is okay. Okay, so now we're just going to click Align. Okay, once we get our result back, we can look at the multiple sequence alignment. In Uniprot, we can also annotate. It has some highlight annotation features we have here in the actual website itself. If you want to do further customization of your annotation, then you can take these sequences, download them, and then upload them to JALView and annotate them the way you want to, or customize. Maybe you're interested in a particular sequence, such as only the peptide sequence itself. The peptide itself might have a signal sequence or a peptide carrier or whatever. You might only be interested in just the peptide that's going to be released in the organism. Okay, but you can notify anything. You can do disulfide bonds. So here's cysteines. Defensins are known for their cysteine bonds. We can color based off of their similarity. Small, tiny, big. We have hydrophobic, helix, and then here's a signal peptide. So like I said earlier, here's a signal peptide. So this might not be what you're interested in. You might be interested in the peptide itself. You can use JALView to take this subsection out. And I think Uniprot can do the same thing. Okay, and here's the propeptides. So beta strands, turns. So this is what you can do with it, but the question's asking for what do the symbols mean. So here, I'll just show the disulfide bonds. Okay, so cysteines, notice there's a star right here. So here we have a star at these disulfide bonds, at these cysteine residues, and the star Notice how in this column there's only cysteine, so the star indicates that this is highly conserved. And then if we look at these colons, that it has K, but it also has E. So here, it's not as highly conserved as the cysteines in these columns with the stars. Stars indicate that there's only one amino acid occurring in this column. Colons indicate that there's probably only one or two amino acids occurring in the column. So it's not as conserved, but it's pretty conserved, right? V, in this column we have L, V, 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 V. And then if we look at the period here, we do have some conservation, but not as it's not as nearly as conserved as the colon or the star. Here, if we look at the period here, we have V, A, A, V, V. There's two A's, and then there's more V's, but notice how there's two A's, right? Look at another one, same case. Here we have, see, it's not as conserved. We do have some conservation, glutamine, arginine, asparagine, but it's definitely, there is some conservation here compared to where there might be no conservation with the blank spaces. We don't have anything. We have different amino acids in each of them. It doesn't appear to be as conserved. So it's from the period to the colon to the star is based off of how conserved that position is in the multiple sequence alignment. And that would be what you would put down here for the answer. And you could snip your multiple sequence alignment here. It doesn't ask for any description. And then homework, it might ask for the description and so forth. Okay, so that is the end of this tutorial. Hope this one was helpful.